Hi everyone. So today we're going to talk about what causes the seasons that we have on Earth. So you should have a sheet that looks like this in front of you. If you weren't able to print it out, my suggestion would be to draw on a blank piece of paper, snap a picture, and submit your assignment that way. Or you could also use Google Drawings. So your page won't look exactly like mine. It won't have the color on it. And that's because I added the color first, because I do think it might make it easier to follow along as I'm talking about these ideas. So the foundation of what we're really talking about is this section up here. Everything below is a visual representation of things we're going to be talking about. So we're going to start with the two things that cause the seasons on Earth. The first of which is Earth has a tilted axis. So you'll notice that I even tilted the word itself. That's a really good memorization technique for you that may help you remember that it is tilted. And what we're talking about when we talk about that axis is there's an invisible line going down the middle of Earth, and this is just to show you what that tilt looks like, how Earth is tilted. So pick any color that stands out to you and color this line that color. And the reason you're doing this is because as we talk about this tilt, you will notice that it never ever changes, no matter where Earth is around the sun. So make sure you have all four of those lines drawn. And this tilt that we're talking about is 23.5 degrees. And it never ever changes. So I'm just going to move this so your eye catches it so you can see where it goes. So Earth's axis is always tilted at an angle of 23.5 degrees. So this tilt plus our movement around the sun, which is what we call a revolution. So revolution is 365 days or one time around the sun. So this tilted axis plus the revolution is what gives us our seasons. So now we're actually going to take a closer look and see what that actually looks like. And the neat thing about learning this is that you can tell where you are in Earth's orbit or Earth's revolution simply by looking out the window and knowing what season it is. So we're going to start with spring because that's the season we're in now. So in spring, the Earth is right here as we move around the sun. So you'll notice there's 4 quadrants. So this is 1, 2, 3, 4. So it's one season per quadrant. If you need to, draw a line from this word spring up to this Earth. Or you could even write spring up here if that helps you remember. So spring is when we are right here in our orbit. So before I get too far, you'll see that I have 3 Earths, have half of them in darkness. This one you can't see, but half of it actually is in darkness. So I want to point out the difference between rotation, which you can see that word right here, and revolution. So revolution is one time around the sun. A rotation is 24 hours, and that's what causes day and night. And you can see this arrow, this pink arrow that I have here, that's Earth rotating on its own axis. So the spinning of the Earth. So at any given time, half of the Earth is always in darkness. It's always nighttime somewhere. And that's due to the rotation of Earth. So, for example, here, the reason you don't see any part shaded is that our sun is right here. So This would be daytime on this side of the earth. The other side you can't see would be nighttime. And I also want to point out, I'm hoping you know this by now, but some of you may not, that when we're talking about seasons, I'm talking about the northern hemisphere, which is this top part of Earth. So this bottom part of Earth is called the southern hemisphere. You live in the northern hemisphere. So back to our seasons. Here we have spring. After spring comes summer. And summer goes right here with this Earth and in this quadrant. So I'm going to pause here because after I talk to you about sunlight, this should make a little more sense. So now I'm going to move up here. You see I have two circles with rays coming off of them. So the first one I want to talk about is this one right here, and this represents direct sunlight. And you can put this up here, you can put it next to it. Just don't get these two confused. So I'm going to put mine right up here. So this is direct sunlight. And this happens in the summer. So back to our illustration down here just for a moment. So it's summer. You can see this tilt of Earth has not changed. The only thing that has changed is in our revolution around the sun, we have moved from here to here. But notice now that the northern hemisphere, which is where you are, is directly facing the sun. So those rays of light from the sun are going to be more direct. They're going to be more intense. This is why it's hotter in the summer than it is in the other seasons. We're receiving more direct sunlight. Even at nighttime, we're receiving more direct sunlight. So the next season we have, after summer comes fall. So that goes in this quadrant right here, or with this Earth. Again, if you need to draw your arrow, feel free to do so, as long as you remember that fall goes with this Earth down here. And after fall, we have winter. And that goes in this quadrant right here. Again, you can draw your arrow if you want, or put winter a little closer to that Earth so you remember which Earth it goes with. So you can see here, my tilt still has not changed, but my Earth in the summer compared to my Earth in the winter, you should notice that the northern hemisphere here is facing towards the sun. But here, even though that tilt has not changed, that northern hemisphere is facing away from the sun. So we're getting now what we call indirect sunlight. And that's when the rays of the sun are hitting the earth like this. And that happens in the wintertime. So I'm hoping now you realize that the tilt of the earth does not change. So that tilted axis plus our revolution, so 1 year or 365 days around the sun, is the reason that we have our seasons. So I talked a little bit about the hemispheres. So now I want to talk about this part down here. So the seasons are opposite. So when it is winter in the northern hemisphere, so right here, and you can see the northern hemisphere is pointed away from the sun, this southern hemisphere is pointed towards the sun. So our winter is their summer. So I'm going to put summer right here. So when it is winter in the northern hemisphere, it is summer in the southern hemisphere. So when it's our spring, it's their fall. And you can remember that just by looking at the opposite season as you look back on this illustration. So there's two more things I want to talk about. You will see I have equinox and I have solstice, and I have different dates with each of these seasons. So twice a year we have an equinox and we have solstice. So I'm going to talk to you a little bit about those. So our two equinoxes, we have a spring one and we have a fall one. The spring equinox occurs on March 21st. And what that means is days with equal amounts of daylight and darkness. So it's about 12 hours of sunlight and 12 hours of darkness. Think equal amounts of day and night. And that happens on March 21st and September 21st. The solstices also happen twice a year. They happen on June 21st and December 21st. And those are both the longest and shortest days of the year. So I am going to move this up here, but I'm going to leave it here just because I think you can see it a little bit better. When I'm talking about longest and shortest days, I do not mean that the day itself is more than 24 hours. What I mean is that the day has more hours of sunlight than it does darkness. That's what we're talking about when we mean longest days. When we're talking about shorter days, we're talking about days that have more hours of darkness and less hours of sunlight. So the solstice is both the longest and the shortest days of the year. So again, the longest days of the year, we're talking about more hours of sunlight, and the shortest days, we're talking about less hours of sunlight. So these are your notes for this page. What I really want you to do is make it your own. You can make your leaves different colors. You can make your rotation a different color if you'd like. You can add little arrows here to show the revolution of Earth. Really have some fun with it and make it your own. My hope is that this Doodle Note page was fun for you, and it's sort of more of a way to connect with me rather than just finding a video on YouTube and giving it to you. I'm hoping making my own video helps you understand a little bit better. So again, if you have questions, utilize the office hours. Shoot me an email at any time. I'm happy to either do a Google Meet or a Zoom if you really feel like your class would like to do that. Whatever I can do to really help you understand these concepts. I know it's a tough time for everybody. We really do miss you guys. And we really are hoping for the best. And one thing that we're really hoping is that our work is not too overwhelming for you. So with that, I will sign off. Have fun with your notes. And don't forget to actually submit them to Google Classroom. Thanks, guys. I appreciate you watching. Bye.